Hi guys, in this video we are going to learn another type of amplification using OPAMP. Here we are going to learn about how an OPAMP can work or can perform as non-inverting amplifier. In our previous video we have learned about OPAMP applications. If you haven't watched those, I have given the link in the description, so please watch that first. So here we are going to derive how to get an equation or how to get a relationship between V naught, V output and V input in a non-inverting amplifier. So here the name suggests that it's an amplifier, it's going to amplify the voltage, and also it's a non-inverting, which means in the previous video we have learned about inverting amplification, which means it will change the phase of the signal. But here the phase of the input signal won't change, and it will directly equal to the output phase. So that's the main ideology. So let's draw the I and mark those I and voltage difference between those values, and let's figure it out what's the value. So here, since I have already mentioned that if since this is a non-inverting amplifier, we are going to give the input signal for the plus. In the previous video, I have mentioned that this plus terminal is known as V plus terminal is known as non-inverting terminal. The reason is to get a non-inverting amplification, we are going to provide that input to that plus. That's why we are going to tell that plus terminal, that positive terminal, as non-inverting terminal. So since this is a non-inverting amplifier, so what we are going to do is we are going to directly give the input to non-inverting terminal. And also what the next step is, we are going to give a negative feedback. Always remember, for many types of application we will use negative feedback. The reason is, if we give the negative feedback only, the plus voltage and the minus voltage will be equate. Otherwise, if you are giving a positive feedback, it won't equate the positive and negative terminal voltage values. So for these types of application, we must have to equate these two values, V1 and V2. That's why we are using negative feedback always. So here we have given the negative feedback, which means we taken from V output the some part of voltage and we are providing to that same input. So this is the main circuit. So let's mark it, the current goes through this path. Some might be wondering whether the current won't be going in this way. The reason is actually no. We have already learned that in input side of an op-amp, don't worry about the current, input current. It won't drain any current from the direct input. It will only drain current from the power sources. But here we don't need to actually worry about those power sources. But when you are concerned about this output, there will be a current and it will go through. Let's mark it like this. In this side, it's going to should be equal, because the current can't go through this way or can't come from this way. So the current which is going through the RF should be equals to the current going through RI. So let's mark the voltages as well. So here the VI should be the input voltage. Since this is a negative feedback, we have connected the minus with the output. We can tell this is going to be VI. From that we can tell this is going to be VI. So now we knew the VI and the current, and we know an RF and RI. So let's make a move to write the equations. And here you can use this Ohm's law separately for this one and this one, and you can equate the current I as well. But here another simple rule which is already derived using these things, so I'm going to use that directly. We are going to derive that it's going to be potential dividend rule. And also you can directly get the equations by equating Ohm's law in these two, and you can equate those values. But potential dividend rule will make those things in a single line. You don't need to consider this I, and you can directly make the uh, relationship between Vi and V output directly without considering any Ohm's law. So how to find this one? So if you need to find the value of Vi, and if that circuit is connected to one voltage in one side and another one is ground, you can use this potential dividend rule. If you don't know the voltage inside and you have provided one voltage outside, this is going to be V out, and one is connected to ground, and there will be two resistors. So if you are having this kind of a circuit, you can directly use this potential divided rule. So how to write this is, you need to write Vi, which is going to be equals to, in the other side, you know, this is going to be V naught into this resistor. It's going to be Ri, V naught into this resistor divided by both, you need to add both Ri plus Rf. So this is the equation. If you can directly use, this is known as potential dividend rule. This can be easily derived by equating this Ohm's law for these individual resistors individually, but also you can directly use if one is connected to V out and another one is connected to ground. So this is Vi is equals to V naught into Ri, which is connected to ground, the resistor, and divided by these two. So here we need to find the V naught divided by Vi to find the what's the gain of that voltage. So how to find that? So if you arrange this equation, Ri plus Rf divided by Ri, yes. So if you write that, you are going to get 1 plus Rf over Ri. So this is the equation. So you can directly use this equation. If you knew the Rf and Ri value of this kind of circuit, which is non-inverting amplifier, you can directly substitute those values and you can get what the voltage gain using this. So this is the main equation you need to remember for non-inverting amplifier. So here you can see in the previous video, for inverting amplifier, we have learned that V naught over Vi is equals to minus Rf over Ri. But here, let's say if you are not providing this Rf, which means if you are directly 100% you are giving the feedback to negative terminal, you are going to get at zero, the voltage gain at zero. But if you are considering about this, if you make this Rf as zero, let's say if you are short circuiting these two without having the resistor, you are going to get anyhow the input voltage as the same as output voltage. So that's the main thing. And here we are not getting an inverted signal. There are no minus, as you can see, but here there is a minus. This is for inverting signal. I hope this is a very simple thing, and you can easily derive and use this equation, but for the exams you don't have enough time, so it's easy to memorize this equation. ABD is equals to 1 plus Rf divided by Ri for this non-inverting signal. If you're having any doubt, please comment it below, and thanks for watching.